Hello, and welcome to the first lesson in pre-calculus, or squeeze. Today we're going to do section 1.1, where we look at the 4 different ways to represent different situations. We can use a table, a graph, a formula, or words. Now, a function is a relation between 2 variables, where each input has only one possible output. We'll talk about this a little bit more tomorrow. But it's saying for every one thing you put into a function, you can only get one possible variable out. We can kind of think of it like a juicer. If I put in an orange into a juicer, the only thing that I'm going to get out is going to be orange juice. I can't put in an orange and get out grape juice. It's the only type of juice I can get out would be orange juice. Now, if we look at this situation, where we have a date in December of 2000, so this is the 19th, 20th, 21st, and so on. The output is going to give us the temperature. So if we're looking for f of 20, what I do is I look for where my x value, or my input is 20, and where my input is 20, my output is 17. So what does that mean in the situation? Well, on December 20th, the temperature my computer's running slow here, is 17 degrees. Now, if we look at coffee temperature over time, say if you heat up some coffee, over time it's going to go further and further down, and it's going to move closer and closer to the actual room temperature. So in words, what I would say is what's happening is the coffee cools quickly, but cools slower and slower as time increases. What I should say, the coffee cools quickly initially, but slower and slower as time increases. That's better. Now, we could also represent that with an equation. This is an equation which turns out to be a exponential equation. We can also write this using a table. Now, if we use a table, the book a lot of times will say express it numerically. So numerically and using a table, those two are synonymous. So if we look at this situation and we see f of 10 is equal to 27.5, what does that mean in this situation? Well, my input is 10 and my output is 27.5. So we can say after 10 minutes, the temperature of the coffee is 27.5 degrees Celsius. All right, now you've heard me say things like independent variable, dependent variable, input, output, domain range, x value, y value. A lot of these are fairly similar terms. The input is for independent variable. The output would be the dependent variable, whereas the domain is for independent and the range is for dependent variables. The x value, y value, and f of x is usually what we say the dependent. We could also, it says it there, but we could also just write x for the independent variable. So this is mostly what we graph on the x-axis. Sometimes we call it input. If I talk about all of the possible values that we can put in there, that's called the domain. Now our y values, or our f of x's, are the outputs, also called the dependent variable. All of the possible dependent variables in a certain situation is the range. Now, sometimes there will have restrictions on domain and range, just like our previous example with coffee. Our previous example starts up here and gets closer and closer to room temperature. Now, one restriction on the domain, if we look at the x values, it doesn't make sense to have negative values here because we're not going to look for coffee 2 seconds before we started recording because 90 might be the max that the temperature of the coffee was ever at. So there are some practical restrictions that we have to think about when we're thinking about the problem. Now, theoretical, there are a couple situations where we know that that something won't work for the domain. Say if I have an equation like this. We cannot have a 0 for x. So x cannot equal 0 because if we have a 0 in the denominator, it would be undefined. Another situation that won't work is x can't be negative under a square root. So x can't be less than 0 under a square root. So both those situations will give us a domain that doesn't work. And here's your homework for tonight.